Hello students, and welcome to our lesson on order of operations. Technically, not our most important lesson in the course. However, it is arguably the most meaningful lesson to me that you understand because I cannot, like, how do I even go about saying this? When I see something on, let's say, social media that uses order of operations, and I look in the comments and it's all these people arguing about what the answer should be, all I can think to myself is, wow, I really hope my students know how to do this because it's always things that I consider to be at a level that everyone should know. And so it is very frustrating to me to think that some people do not know it. So hopefully by the end of this lesson, you will no longer be one of those people. And again, it's not that this content is super important for our real life, it's that it's super important to me. So please, for me, okay, for your good old professor here, please pay special attention to this video. That way you have order of operations down for the rest of your life. Okay, that being said, let's go ahead and dive straight into this thing. Exponents on negatives. So exponents represent repeated multiplication. We have seen this exact diagram before in our essential skills lesson, where a to the n means to take the base of a and multiply it by itself n times, okay, where n is that exponent. Now, what we're going to add to this is what to do when negatives are involved. All right, we saw how exponents work for positives, but what if there's a negative? So a negative number raised to an odd power, such as maybe -3 to the power 3, this is going to result in a negative product. Because when we multiply a negative times a negative times a negative an odd number of times, only some of the negatives cancel out and we have one left over. So for example, this -3 to the power 3, if we actually work this out, this is -3 times -3 times -3, and this equals -27. Because the first two negative signs cancel each other out to make a positive, but then that third negative sign multiplies with the positive to turn it back into a negative. So all you have to remember is that if the exponent is odd and the base is negative, then you will have a negative answer at the end. However, if we have a negative number raised to an even power, then this result will be positive because all the negative signs will cancel each other out in the middle. Okay, next note is that parentheses matter. So there are two problems written down below there. They're exactly the same except one has parentheses, and that makes a big difference. The one on the left, -3 in parentheses to the power 2, means -3 times -3, and that is +9. The one on the right, though, has negative and then 3 to the power 2. This negative sign is on the outside. So we're actually doing a negative sign and then 3 times 3, where each of those individual 3's are positive. Okay, that negative sign is just out in front of the 3 squared. So this results in 3 times 3 is 9, and when you put the negative on it, we get -9. So notice those parentheses made one answer positive and one answer negative. Do not fall into the trap of not paying attention to parentheses. All right, now let's do some examples with the exponents. We have number one is 2 to the power 3. We've actually seen this in the essential skills lesson. We are supposed to know that 2 to the power 3 is 8. Okay, that is one of the cubes that I wanted you to memorize. So 2 to the power 3 is 2 times 2 times 2, and this just equals 8. Number 2, though, now we're going to put a negative sign on that 2, and we're going to do -2 in parentheses to the power 3. This means -2 times -2 times -2. And because there is an odd number of -2's there, we're going to get a negative result. So we're going to end up with -8 as our solution. The 2's multiply just like before to give us 8, but because there's an odd number of negative signs, we get a negative in our answer. Number 3, we have a negative sign and then -2 to the power 4. So that negative sign that's out in front, just like the example that's right above it, that's going to stay in front. But then we're going to have 4 -2's all multiplied together. So now, because we have an even number of negative 2's, those negative signs will cancel each other out, but that red negative sign, that's going to stay in front. Okay, so that one's not going anywhere. Our answer is going to be negative. So again, these 4 2's here, all these negative 2's cancel out the negatives, but this negative that was in front is going to stay out in front. So we end up in total with 5 negative signs. So since that's an odd number, one of them stays behind. And then if we work out 2 times 2 times 2 times 2, that gives us 16. So we end up with negative 16 as our result here. So again, just being careful with negative signs. The last one is a negative and then 2 to the power 4, where that negative is not in parentheses. So that negative sign is just out in front. And then 2 to the power 4 we already saw is 16, but this is 2 times 2 times 2 times 2, where these are all positive 2's. So when we work this out, we just end up with that negative sign that's in front, and then those 4 2's together give us 16. So now notice something real quick. Negative 2 to the power 4 gave us negative 16, but negative positive 2 to the power 4 also gave us negative 16. So now how does that end up happening? Well, they both have an odd number of negative signs. In number 3, we had 5 negative signs, and in number 4, we only have 1 negative sign. But since both of those numbers are odd, we end up with negative results in both cases. All right, now the meat of this lesson, the order of operations. This is going to tell us when you see a problem, such as those ones down below, what do we do first, and then next, and then next, and then next. So we have a nice easy acronym to remember this. The acronym is GEMDAS, GEMDAS. Okay, you may have seen this in other courses as PEMDAS. Okay, and the only reason I use a G instead of a P is because the P always stood for parentheses, which you can see right here, is one grouping symbol. But the G, which we're going to say stands for grouping, this could mean a lot of different things, not just parentheses. So it could mean parentheses, but it could also mean brackets or absolute values or a whole bunch of other things that we just haven't learned yet in this course. So grouping symbol is what that G is in the GEMDAS. Then after grouping, then we will do exponents. After exponents, M and D stand for multiply and divide. And we just do this from left to right normally. And then A and S stand for add and subtract, or addition and subtraction. So add and subtract, or addition, subtraction, whatever you prefer there. And then one note, I have mentioned this in a previous lesson, but just as a reminder, a number in front of a grouping symbol means to multiply. So if we have 3 right here in front of this set of parentheses, 7 plus 2, that's the same thing as putting this little multiplication dot between the 3 and the parentheses, but we don't write that dot because it's quicker to just put it up against the parentheses. So you just have to remember that this 3 means to multiply right here times the parentheses. All right, so now some examples with grouping. What we're going to do is we're going to build up to higher and higher levels of grouping symbols, or of order of operations, I should say. So the first one, we just have parentheses and multiplication. Okay, so what we do is apply the order of operations in the order those letters appear in GEMDAS. So first we look for grouping symbols, and we notice we have some parentheses here. So we're going to do what's inside of the parentheses first. So we're going to simplify 6 plus 2 to be 8. And the rest of the problem, let me write that 8 in blue actually. So we're going to get 6 plus 2 is 8. And then we're going to do the times 5 afterward. So I do the grouping symbols first. And then I look back at my list of letters up there. And I go, okay, there's no more grouping symbols. There's no exponents. The next thing that shows up is to multiply, which we have. So now we'll multiply 8 times 5 to get 40. Remember, by the way, in our essential skills lesson, topic 1, I told you guys it's very important to know how to do single digit multiplication quickly. So right there, 8 times 5 is 40. That is just a fact that I want you to know. I do not want you to have to pull out a calculator to do single digit multiplication ever. So 8 times 5, we should be able to jump straight to 40 there. All right, number 6, we have 4 up against some brackets and then 3 plus 7 inside. So the first thing we do is the grouping symbols. So inside here, we have 3 plus 7, which is 10. And the rest of the problem is this 4 out in front and that 10 still in brackets. Now we don't have any more grouping. We don't have any exponents, but we do have multiplication because a 4 up against brackets means to multiply. So 4 times 10 here gives us 40. And it's a coincidence that we got 42 times in a row. Don't read into that. All right, next one, number 7. Now we got some negatives involved. We have a -2 up against an absolute value of -10 plus 6. Absolute value, we've talked about in the past, counts as a grouping symbol. So we're going to work out inside the absolute value first. -10 plus 6. Remember, when you have different signs, do big number minus small number. So 10 minus 6 is 4. But because the 10 is negative, and that's the bigger number, I'm going to put -4 inside here. So now we have -2 up against the absolute value of -4. Now we're going to do the absolute value. So the absolute value of -4, that's the grouping symbol we have to work out here. So absolute value of -4, let me do it in red real quick. That just gives us +4. And because I know that there's multiplication between the -2 and that absolute value sign, I'm going to put this 4 in parentheses to make it clear that I still have to multiply right here. If you don't put those parentheses, it just looks like the number -24. But we need to multiply still. So now we do that multiplication. -2 times 4 is a negative times a positive. So we get a -8 from that one. Okay, the mistake most students will make here is multiplying -2 times -4 in this step. But we have to do that absolute value symbol before we do the multiplication, because the absolute value is a grouping symbol, and grouping comes before multiplying. All right, now we're going to add some layers to this. Number 8, we have 12 minus 3, and in parentheses 8 minus 3. Most students mess up by doing this 12 minus 3 right here and saying that there is a 9 in front. That is not correct. All right, we need to instead focus on grouping symbols first. So in parentheses here, we have 8 minus 3. I'm going to turn that into 5. So now we have 12 minus 3, and then in parentheses is that 5. So now still, you might want to do 12 minus 3 to write 9 there, but we have multiplication that comes before subtraction. So we need to do 3 times 5 first, and then we can subtract. So we have 12 minus 3 times 5 is 15. And then now that subtraction is the only thing left, now we do 12 minus 15 to get -3. But very important that we do the grouping symbols first, and then the multiplication before we do that subtraction. Okay, that subtraction comes last. Number 9, very similar. We have 20 minus 1 up against brackets 15 minus 9. Those brackets are grouping symbols, so I do 15 minus 9 on the inside to get 6. The rest of the problem stays the same. And this one is a little bit funny because we have a 1 in front of that 6 right there. And sorry, let me actually put brackets around the 6 instead of parentheses, since we had brackets originally. They mean the same thing, but just to match the problem. So now you might be tempted to do 20 minus 1 to get 19 here, but we have multiplication between 1 and 6. So I need to work that multiplication out first to get a 6 here. And then now we're going to do 20 minus 6 as our last step, and that gives me +14. Number 10, we have 50 plus 2, absolute value of -7 plus 2. So I'm going to work on the inside of this absolute value first. -7 plus 2 is -5. Then I'm going to rewrite the absolute value symbols and the 50 plus 2 in front. Now we need to take that absolute value. We need to evaluate the absolute value of -5, because remember, absolute values are a grouping symbol. So the absolute value of -5 is +5. And then we still have this 50 and 2 in front. And I put parentheses now around my 5 to make sure it's clear that I am multiplying right here, because originally I had 2 up against these grouping symbols. So there's multiplication between the 2 and those grouping symbols. So these parentheses here make it clear that I need to multiply right now. And we do the multiplication before the addition. So I'm going to do 2 times 5, which is 10 first. And then now addition and subtraction always come last. 50 plus 10 gives me 60. All right, now we're going to include a little bit more. Now we're going to have some exponents. So number 11, we have 7 times 2, and in parentheses 3 squared minus 4. the first thing we do is look inside of the grouping symbols. So we see 3 squared minus 4 on the inside. Now, once we're inside the grouping symbols, then we restart the process if there's multiple things to do. So we can't do 3 minus 4 yet because there's an exponent inside those grouping symbols. So what I have to actually work out first is not 3 squared minus 4, but it's actually just 3 squared, which is 9. So the rest of the problem is going to stay the same. Okay, 7 times 2 in front, and then 9 minus 4 is what I have on the inside now. Now that I handled the exponent, now I can do what's normally inside the grouping symbols, which is just 9 minus 4, which gives me 5. So I now have 7 times 2 parentheses 5. And now I'm down to all multiplication. So 7 times 2 is multiplication, and 2 attached to the 5 right there is multiplication. So because it's multiplication everywhere, we can just multiply across. So 7 times 2 is going to be 14, because we're going to do what's on the left first. And then 14 times 5, well, if we're doing 2-digit multiplication, sometimes it's helpful to write it on the side. So 4 times 5 is 20, so I put a 2 on top. 1 times 5 is 5, plus 2 is 7. So we end up with 70 here as our final answer. So just to be clear, when I was in this step right here, I had multiplication in 2 places, so I did it from left to right. 7 times 2 gave me this 14, and then 14 times 5 gives me my final answer of 70. All right, number 12, a little bit more going on now. We have 18 divided by 3 plus 2 squared plus absolute value negative 5. Okay, first we're going to look inside these brackets. But then once we see those brackets, then we're going to look even deeper inside and see that we have a grouping symbol right here, and it's this absolute value of negative 5. So before I do anything else, I need to do that innermost grouping symbol. Absolute value of negative 5 is just 5. And then we can go ahead and rewrite the rest of the problem. 18 divided by 3 plus bracket 2 squared plus 5, and the bracket. All right, so now we restart. We have brackets, which are grouping symbols. So I look inside, and just like the previous problem, inside those brackets, I have an exponent. So I will work out that exponent before I do the addition. 2 squared is 4. So then I rewrite out 18 divided by 3 plus bracket 4 plus 5. Now in those brackets, I can go ahead and work out that addition. 4 plus 5 on the inside gives me 9. So I'm now left with 18 divided by 3 plus 9. And now we can actually do the division because we only have 2 operations left, division and addition, and division comes first. So we're going to work out 18 divided by 3 first to get 6. And then once we've done that, now the only thing left is to do 6 plus 9, which gives us 15. All right, one more here. Number 13, we have 4 plus 2 absolute value of negative 3 plus 1 squared times 2. A lot going on here. Notice a grouping symbol with a negative 3 plus 1 inside. So inside that absolute value, we're going to work out negative 3 plus 1 first, which is just negative 2. So then we're going to rewrite everything around it. 4 plus 2, absolute value negative 2 squared, and then times 2. Okay, now the grouping symbol of absolute value is still there. So you might be tempted to jump straight to squaring, but we actually have to evaluate the absolute value first. So before we can do that square, we have to first just evaluate what is the absolute value of negative 2, and that is positive 2. I'm going to put this positive 2 in parentheses to make the next step a little bit more clear. We have a 2 in front of those parentheses, a square on it, and then a times 2 in the back. All right, now we have a few things going on here. We have addition, we have multiplication, we have an exponent, and we have more multiplication. So the exponent comes before all of those multiplications. So what I'm going to do next here is do 2 squared in the middle, which gives me 4, and the rest of the problem is going to stay 4 plus 2 times 4 times 2. Okay, now I have multiplication in 2 spots. I can go ahead and multiply it all together at once. 2 times 4 is 8, and then times 2 again is 16. So 2 times 4 is 8, times 2 is 16. So I can put this all together as 4 plus, and then all of this right here gives me 16. And we just finish off by doing the addition. 4 plus 16 is 20. Oh, that one was a bit of a doozy, wasn't it? All right, now let's do the same stuff, but now we're going to evaluate for a given variable. So number 14 says, if x equals -3, evaluate 2x squared minus 3x plus the absolute value, x minus 5. First thing we're going to do is just take this -3 and replace it for all of these x's in the problem. Now remember from previous lessons, whenever we evaluate or substitute for a variable, we need to use parentheses. So wherever I see an x right now, I'm going to leave a little bit of a space with some parentheses in it. And then afterward, I'm going to put that -3 inside. So everywhere I see an x, I'm writing a set of parentheses. And then now in those parentheses, I'm going to put that -3 that x is equal to. So notice I had 3 x's in my original problem, and now I have 3 -3's plugged in, one in each spot. All right, but now we just pretend as if it's one of the previous examples, where we have grouping symbols in that absolute value we got to deal with first. So we're going to go ahead and simplify over here on the right side. -3 minus 5 is -8. So we have 2 times -3 squared minus 3 times -3 plus absolute value of -8. Next thing is still the grouping symbol of those absolute values. So we're going to go ahead and work out the absolute value of -8 is +8. So we now have 2 times -3 squared minus 3 times -3 plus 8. Okay, now we move on. We have multiplication between the 2 and the -3, and right here between the -3 and -3. But before we can do either of these multiplications, we have to first do this exponent that's on the -3. So remember from the beginning of the lesson, when we have a negative number to an odd, sorry, in this case, an even power, we're going to get a positive result. So -3 squared right there is going to give me +9. So I now have 2 times +9 minus 3 times -3 plus 8 in the back. Now I have multiplication in two different spots. I can go ahead and work out both of these at the same time because they don't affect each other. 2 times 9 in the front is 18, and 3 times -3 is -9. So then the rest of the problem in between, I have a minus sign in between the 18 and the -9 because this symbol right here just drops straight down. And I still have a +8 in the back. Now I can just go ahead and work out the addition and subtraction here. We have 18 minus -9. That's the same thing as 18 plus 9. So this right here gives me 27. 18 plus 9 is 27. And then 27 plus 8 gives me 35. So this all results in 35 as a solution. Number 15 up there, we have a equals -2, evaluate 5 plus, parentheses, a plus 7 squared minus 2 absolute value of a. So we're going to have to put this a being -2 in two different spots. So when we rewrite this, we're going to have 5 plus parentheses. Where I see that a, I'm going to put another set of parentheses, and then plus 7 squared minus 2 absolute value of, and I'll put parentheses inside. And then where I put those parentheses, I just put a -2 in each spot. But remember, those parentheses are important to make sure we're doing the right operations. So you saw in the previous problem right here, 2 times -3 squared. If I didn't put that -3 in parentheses, that was not going to make any sense, right? It would say 2 minus 3 squared. Not the same thing as 2 times -3 to the power 2. So parentheses very important when we're substituting for variables. Back to our current problem though. We have two different grouping symbols to look at. We have parentheses with a -2 plus 7 inside, and we have the absolute value of -2. We can go ahead and do both of these since they don't affect each other. So in the middle, -2 plus 7 is +5. And on the right, absolute value of -2 is +2. So now we're going to go ahead and put both of these in parentheses because they were in parentheses before. And the absolute value was a grouping symbol before. So I just replace it with parentheses after I do the absolute value. So we now have 5 plus 5 squared, don't forget the exponent from that set of parentheses, minus 2 times 2. So now in the middle, we have an exponent. So we're going to do 5 squared. That's 25. So we now have 5 plus 25 minus 2 times 2. We can do that multiplication in the back. 2 times 2 gives us 4. So we now have 5 plus 25 minus 4. And then because we're down to addition and subtraction, we can do it all at once. 5 plus 5 is 25. Sorry, 5 plus 25 is 30. And 30 minus 4 is 26. So we end up with 26 as our final answer here. And that was a lot of operations work. Wow. All right, let's get through a couple applications here. Make sure we can do this in context now. So a club plays let's try that again. A club pays a setup fee of $25 plus $7 per student for 12 students, and then buys 3 bundles of decorations at $8 each. Write and evaluate an expression to model the club's expenses. So we have a few things going on here. We have a setup fee of $25. We have $7 per student for 12 students. And then we have 3 bundles of decorations that are $8 each. So we need to then add together each of these expenses. So that original setup fee of $25 will go first. And then we are paying $7 per student for 12 students. So that is going to be $7 multiplied by 12. So 7 times 12 in the middle there. And then we're buying 3 bundles at $8 each. So we're going to have then 3 bundles times $8 each at the end. So now my parentheses were not technically necessary here, but I think it just keeps everything nice and tightly together. We have $25 plus 7 times 12 for the cost per students, plus 3 times 8 for the cost of the decorations. If we work this out, okay, we have a couple multiplication spots. So 7 times 12 is 84, and 3 times 8 is 24. So all we have to do is add together 25, 84, and 24. So because these numbers are a little bit big, we're going to do this one step at a time. 25 plus 84 is 109. And then we still have to add 24 to it. 109 plus 24 is going to give us 100 and let's see, 1333. So we end up with a total cost of 133. And notice I threw a dollar sign on it at the end there because we are talking about money and an expense to the club in this case. All right, number 17. A hiker starts at 200 feet below sea level, climbs 150 feet, descends 40 feet, and then descends 40 feet 2 additional times, then climbs 90 feet. Oh, we're going up and down. Okay, so let's go ahead and highlight in red and green here. We start 200 feet below sea level, so that's going to be a negative because we're below sea level. Then we climb, meaning we go up 150, so that's going to be a positive. Then we descend, meaning go down 40 feet. Then we descend 40 feet 2 more times. Okay, so that's going to be 2 times 40. And then we climb, meaning go back up 90 feet. So we got to put together all these different elevation changes. So our initial starting position is negative 200 feet because we're 200 feet below sea level. Then we go up 150, so we're going to add 150. Then we go down 40, so minus 40. And then we go down 40 2 more times. So instead of writing minus 40, I'm going to subtract 2 times 40. Okay, because we did 40 twice. And then we climb 90 feet, so we add 90 at the end. All right, so now, although we could do this by hand, I think this is a great opportunity for me to introduce that we are allowed to use calculators in math. They do make our life a little bit easier, and they will actually do the order of operations largely for us. So the only thing I'm going to do before I pull out the calculator and type this in is I'm going to multiply 2 times 40. So I'm going to simplify this to be negative 200 plus 150 minus 40 And then 2 times 40 is going to give me a minus 80 here, and then plus 90. So now, again, we could work that all out by hand, but I want to show you guys what Desmos looks like. So right here, you can see Desmos Scientific Calculator. And all I have to do is type in minus 200 plus 150 minus 40 minus 80 and plus 90. And it'll combine all those numbers for me to give me a negative 80. You can see the result on the right side of the screen there. So when we put all these together, this ends up equaling negative 80. And so because we are trying to evaluate an expression for the final elevation, it would help if we express this in words. And so the final elevation is 80 feet. And because it was negative, we're going to say 80 feet below sea level. All right, so after all that up and down, we still end up finishing below sea level. Okay, one more for us here. A team runs 4 sets of drills. Each set has 6 short sprints and 2 long sprints. Each short sprint is 30 yards and each long sprint is 50 yards. Write and evaluate an expression for the total number of yards run. We're going to actually do this one using variables. Since we learned how to evaluate for variables and we have both short and long sprints here, let's go ahead and try to use some letters to actually make this an algebra class a little bit. So we have 4 sets of sprints being run. So because we have 4 sets of drills, I'm going to multiply 4 times however big one drill is. So I'm going to put in parentheses here. And what's going to go in those parentheses is the drills that we do. So it's 4 times however big one drill is. So now, each set of drills has 6 short sprints and 2 long sprints. So I'm going to represent 6 short sprints using 6, and then I'm going to put the letter X here, where I'm going to say on the side, X represents short sprints. Okay, so 6X means 6 short sprints. And then we're going to include 2 long sprints. So we're going to be adding to these short sprints 2 long sprints. So I'm going to put 2y, where y is going to represent long sprints. So on the side, I'll define my variable. Y is long sprints. Okay. And then later it tells us how long a short and a long sprint are. But for right now, we have this expression 4 times 6x plus 2y. Okay. That adequately represents 4 sets of drills where we're doing 6 short sprints and 2 long sprints in each drill. Okay, but now we're going to actually plug in the numbers for x and y. We have that a short sprint is 30 yards and a long sprint is 50 yards. So instead of 6x and 2y, now I'm just going to plug in the numbers for x and y. So we're going to rewrite this as 4 times 6 multiplied by 30 yards for a short sprint plus 2 multiplied by 50 yards for a long sprint. Okay, so we have now evaluated, or at least substituted in, the value for the variable. Now we go ahead and use order of operations to simplify. So inside of the grouping symbol, inside of those parentheses, we have 2 sets of multiplication. So I'm going to work out the first one, 6 times 30 is 180. And the second one, 2 times 50 is 100. So now inside those grouping symbols, we've done the multiplication. Now we can do the addition. 180 plus 100 is going to give me 280 inside. And so now we just have to work out 4 times 280. And that one's big enough that I'm going to do it as a vertical problem. 280 times 4. 0 times 4 is 0. 4 times 8 is 32. So I carry the 3 over. 4 times 2 is 8. Plus 3 is 11. So I end up with 1,120 as my solution. And so when we write out the total number of yards run, we would say 1,120 total yards run during these drills. So total yards run. All right, so the variables there were not necessary, but I felt like it was a little bit enlightening to include those. And we're going to be doing a lot of algebra later in this course where we do involve variables such as x and y all the time. So it's nice to get us comfortable working with them here towards the beginning of the course. All right, that's all I got for you guys in this one. I hope you enjoyed it, and I'll see you next time.